Assalamualaikum warahmatullahi wabarakatuh. So, from our group, we are group 5. We will talk about alcohols, and in specific is about oxidation and Iodoform reaction by Naura, Mahira, Aliya, and Jasmine Shafa from 11 Cambridge Science.
Here are the list of the slides that we will present. First off, we are going to show a brief introduction about alcohols, oxidation reaction, and also iodoform reaction. And last but not least, we are also going to give some exercises and the explanation of the answer. The introduction of the alcohols. Alcohols is the organic compound that can be classified as primary, secondary, or tertiary depending on how many alkyl groups are bonded to the carbon atoms.
Properties of alcohol. The boiling points increase as the number of carbon atoms increase due to stronger van der Waals forces. Alcohol soluble in water due to their hydrogen bond between water and alcohol molecule. Alcohol react with active metals. The acidic nature of alcohol is due to the polarity of the hydroxide bond.
Next, structure of alcohols. Alcohols are organic molecules assembled from carbon, oxygen, and hydrogen atoms, and it also has an angle of 109 degrees.
Now we're going to talk about oxidation reaction. In primary alcohols, they are oxidized to aldehyde and carboxylic acid. In secondary alcohols, they are oxidized to ketones, and tertiary alcohols are oxidized to water. The after-heating colors for primary alcohols and secondary alcohols are turned into green, and tertiary alcohols turn into orange. The oxidizing agents are potassium dichromate and chromium trioxide. Both of these are used along sulfuric acid and water. And these are the overview of the primary, secondary, tertiary alcohols of oxidation reaction. First, primary alcohol. With a primary alcohol such as ethanol, the alcohol is oxidized to an aldehyde. Ethanol is oxidized to ethanol. The ethanol formed can be further oxidized to form ethanoic acid or carboxylic acid. This is achieved by refluxing with excess acidified potassium dichromate. A secondary alcohol, such as propan-2-ol, will be oxidized to form a ketone. In this case, propanone is formed and the reaction mixture turns green. Tertiary alcohol. With tertiary alcohol, a mixture of the tertiary alcohol, dilute sulfuric acid, and potassium dichromate, solution remains orange when warmed. No reaction takes place under these relatively mild conditions.
Introduction to Iodoform reaction. We can find this reaction in Iodoform test. Iodoform test is a test for metal ketones. So if you have a ketone that has a methyl group, it's going to give a positive iodoform test, which is basically a mixture of iodine and hydroxide. Then what's going to happen? The ketone is going to be oxidized into carboxylate ion. Then the metal group is going to be attached into 3 iodine atoms. The product of this reaction known as iodoform, and it's shaped as solid yellow precipitate, and this gives a positive iodoform test.
As we've mentioned above, Iodoform reaction is a specific reaction, meaning there's only certain compounds that give a positive Iodoform test. And for example, there are two specific structures, which is the methyl ketone and the secondary alcohol with methyl group. And also there are two types of alcohol that give this Iodoform test a positive result, which is primary and secondary. For primary, we have ethanol, and secondary, we have secondary alcohol with methyl group.
The question is, which alcohol will react with an acidified solution of potassium dichromate to produce a ketone containing 6 carbon atoms? The answer is B, 2-methylpentane-3-ol, because only secondary alcohols react with acidified potassium dichromate to produce ketone. In this case, the only secondary alcohols is only B, which is 2-methylpentane-3-ol, and they are reacting with acidified potassium and they produce ketone.
I'm Shiva and I'm going to read you some of the questions of the oxidation reaction. Sorbitol is an artificial sweetener used to sweeten chocolate which is suitable for diabetics. Which functional groups can be produced when this molecule is subjected to oxidation under suitable condition? As we can see, there are primary and secondary alcohols in the sorbitol structure. From what we have learned, primary alcohols are oxidized to form either aldehyde or carboxylic acid, and the secondary alcohols are oxidized to ketone. From this statement, we can confirm that the correct answer will be A, which is 1. Aldehyde, 2. Carboxylic acid, and 3. Ketone. Move on to the next question. Compound X changes the color of acidified sodium dichromate from orange to green. 1 mole of X react with 2 mole of HCN. What will X be? We can analyze each of the answer below. From the structure of the multiple choice A, we can see that there is a ketone structure, which means that it will not get oxidized, which establishes that there will be no color change. From the structure of the answer B and C, we can tell that they only have one aldehyde structure, which means only 1 mole of HCN needed, whereas we need 2 mole of HCN. If we analyze the structure of the D answer, we can find that it has 2 aldehyde structure, which means 2 mole of HCN needed, which is exactly what we have been looking for. And it must be remembered that the functional group in it, which is aldehyde, can be oxidized into carboxylic acid, which means that it is the primary structure that turned the orange liquid into green. From this analysis, we can confirm that D is the correct answer.
Which compound shows optical isomerism and gives a positive test with alkaline aqueous iodine? We have to name every compound into IUPAC nomenclature. For example, option A, we have 3-hydroxybutane-2-on. The compound is substituted by a hydroxy group at position 3. Then we can sketch the structure using the IUPAC nomenclature. Here we already have the sketch of the isomer structure and it's shown. It is an optical isomerism. And 3-hydroxybutane-2-on gives positive test with alkaline aqueous iodine because it produces solid yellow precipitate. Some vegetable oils contain trans fats that are associated with undesirable increases in the amount of cholesterol in the blood. In these oils, the word trans describes in the usual way the arrangement of groups at a carbon double bond. In the diagrams below, R1 and R2 are different unbranched hydrocarbon chains, which diagram correctly shows an optically active trans fat. So we already have the answer. The answer is B. So first we have to determine which one is trans and cis. Here we need trans. So the option C and D is cis. So we have to remove the option from our answer choice. Then, after eliminated the answer choice, determine which one that has optical isomerism. So we need a chiral, a carbon which is connected to 4 different groups. Here we already have the answer, which is B. This one is optical isomerism because the carbon connected to 4 different groups.
Next question is, when X is warm with acidified potassium dichromate, there is a color change from orange to green. What could be the identity of X? The answer will be A, because B is a tertiary alcohol. Since tertiary alcohol doesn't react, doesn't oxidize, thus the color stays orange. And A, C, D have primary or secondary, so there a possibility that they could be the identity of X, but C and D has the same molecular formula, which is C3H8 and O. And A has a different one, which gives us a slight hint that maybe that is the answer. Thus, we prove it with the equation of mole and molecular relatives and also mass. And we have a mole of calcium carbonate, which is 3, and divided by 100.1 equals of 0.03. And we divide it again by 4, which is a mole of the alcohol X, and the result is actually the same, is equal to the mole of the alcohol X mentioned in the question. Thus, it proves that A is the answer, that A is the identity of X. Exercise number 28. Which region could be used to carry out the following reaction? The answer is A. The compound above is the aldehyde becoming a carboxylic acid. This is a part of the oxidation reaction of the primary alcohol. The primary alcohol transform into aldehyde and then react again and then produce carboxylic acid. And for the oxidation reaction of primary alcohol, we use a solution containing acidified dichromate ions. So the answer will be A. This ends the presentation of alcohols by Group 5. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.